Okay, I'm back. And so in our previous segment, we talked about the ideal gas law, which said that as the pressure of a gas increases, it's going to increase its temperature. Some everyday examples of this would be, let's say that you've got an aerosol can and you press down on the button on the top of the aerosol can and out shoots the gas. So the pressure of the gas is decreasing because it's coming out. And so that means that according to the ideal gas law, the temperature is going to decrease. So if you feel that can, as that stuff is coming out, you'll notice that the can is getting colder. So that's an example of that PV equals NKT thing. Well, the sun is the same way. So the deeper that you go into the sun, the pressure is going to increase because just like on Earth, we feel 1 atmosphere of pressure here on Earth. So that's the atmospheric pressure. And so that is the weight of about 500 miles of air pushing down on top of us. So that the deeper you go into an atmosphere, the higher the pressure gets. And now, according to this PV equals NKT thing, that means that the deeper you go into an atmosphere, the higher the temperature will become. So let's take a look at Earth, for example. You'll notice that you have this general trend that the deeper you go inside the Earth, the pressure increases, and so does the temperature. Okay, the picture that's right next to it is of Jupiter, and we talked about Jupiter in unit number 2, and we found out that the deeper you go into the atmosphere of Jupiter, the pressure goes up, and so does the temperature. And then, now let's look at the sun. So the deeper that you go inside the sun, you'll notice that the pressure is going up, and so is the temperature. And notice that the pressures and the temperatures inside the sun are much higher than the pressures and the temperatures that are inside of Jupiter, because Jupiter is smaller than the sun. So that means it's got less stuff on top of it pushing down, so its pressures are going to be less. And also the temperature is higher inside of the sun because of the nuclear explosions that are going on inside there. And you don't have nuclear explosions going on inside of Jupiter. Okay, in our next segment, we're going to talk about what do we mean by density, and then what is the density of the nucleus.